All right, we are live with the Space Resources Technical Committee, Google Hangout number 1.
Okay.
Laurent, would you want to kick it off?
Should I start? Okay.
YouTube's online.
Good morning, everybody. For those who are just at the edge of lunchtime on the Eastern Coast in the US, and since our audience is we hope global or soon to be global, then good evening to our friends in Europe and maybe to the night owls in Asia and Australia. So my name is Laurent Sibille. I'm the chair of the AIAA Space Resources Technical Committee at the AIAA. And we are launching today our first Google Hangout on the very general topic of space resources. We are initiating this format of communication to broaden our outreach in the community that spans several continents now, and enhance the value of having regular communications between both members of our technical committee, but also giving an opportunity to the space resources community of researchers and technology developers and managers to exchange views on topics, to make presentations to each other outside of conferences, and to get to know each other better and their work. So today we're going to start with a format of an informal discussion among several people who have been active in this field for quite a while and represent various perspectives. And I'm going to ask them to introduce themselves one by one. So let's start with Diane.
Hello, thank you, Laurent. My name is Diane Linne. I work at the NASA Glenn Research Center. I'm currently the project manager for the ISRU Technology Development Project at NASA. And I'm a past chair of the Space Resources TC. So I want to thank Laurent and the others on this that are running it now for trying something new to get us branching out.
Very well. Let's go to Chris.
Let me unmute myself there.
Right.
Hi, this is Chris Dreyer. I am a research professor at the Colorado School of Mines. I am part of my work at Mines. I'm in the Space Resources program here at Mines. And I'm the current technical committee vice chair. So I'm happy or glad to get this going and hope to have a really lively discussion.
All right, thank you. Go to Gary. You're on mute, Gary. Still muted.
Now I think I've got it. Can you hear me now?
There you go. Yeah, we can hear you.
Sorry, this is all new, this software here. I'm in Luxembourg. I work with the Luxembourg Space Agency, recently retired from NASA. But as you might have heard, hopefully you've heard that space resources are a major focus of our long-term vision here in Luxembourg. So I do quite a bit in that area. So thanks for inviting me.
Very good. And just for the record, for everybody listening, so your full name is Gary Martin. Very good.
Yes. Yes.
All right. Let's go to Paul.
All right. Hi, my name is Paul Van Susante. I'm currently a senior lecturer, soon to be assistant professor here at Michigan Technological University, working on research to ISRU, doing work on Mars and hopefully soon on Moon stuff as well. And I'm the AIAA Space Resources Technical Committee Secretary. So I'll be working with the people that are on YouTube and have questions. I will convey that here to Google Hangout. So if you have any questions, type it there, and I will try to convey it here by typing it in the chat on the Google Hangout one.
Great. Thank you for your help, Paul. And Jürgen.
Hi, everyone. Great to be here. My name is Jurgen Schleppi. I'm in Germany at the moment. I have a background in instrumentation, worked with ESA and the European Astronaut Center for about 5 years now. And for the last 3 years, for my doctoral thesis, I've been looking at how we can utilize the materials on the moon to build something useful, and in particular, solar conversion devices such as mirrors or solar cells on the lunar surface. And I'm really keen to have a chat with you guys, because last year when I met Laurent and Paul in the US, we started having discussions, and it's really nice international feedback and not just like local feedback in Europe, really.
Very good. Thank you, Jürgen. And last but not least, Forrest, who started, but we need an introduction.
Hi, my name's Forrest Meiyan. I'm the Education and Outreach Chair for the AIAA Space Resources Technical Committee. So here we are doing some outreach. I hope everyone is enjoying it. So don't forget to ask your questions. I am a senior member of the technical staff at Draper Labs. I work at Spacecraft Avionics Systems, and I'm primarily focused on our Lunar Lander program. And I also am a science team member for Mars 2020 for MOXIE. So my PhD was on extracting oxygen from the atmosphere of Mars. So a good example of space resources.
Very good. Thank you, Forrest. So just for the audience, we plan to have this discussion for about, no more than 45 minutes. So that you can move on to your life, and just to give you a heads up on how long we're going to go. So as you can see, we have a group of people who are going to bring various perspectives from different corners of the field, and also from at least 2 continents. So we're going to cover quite a bit of topic, but our theme today is Lunar ISRU, so the use of space resources on the moon, and what will the next decade look like. And so just to give a context a little bit, at least, so in the US, NASA is now engaged in a lunar program following Space Policy Directive 1 that was given to NASA, which states that beginning with missions beyond low Earth orbit, the United States will lead the return of humans to the moon for long-term exploration and utilization, and followed by human missions to Mars and other destinations. And actually, NASA Administrator Brendan Stein describes NASA's plan as a 2-phase approach recently that emphasizes speed first, followed by sustainability. And Forrest, you can show this first chart that we had planned, just to show that the NASA approach, it fits actually within that decade, the coming decade, with procurements of landers from the industry, small capability landers at first that will demonstrate landing on the moon, and moving on to larger landers. So that would be, yes, this chart. With a collaboration between science, the Science Mission Directorate, SMD, and the Human Exploration Operation Directorate, HEO. And as you can see, it goes, and the goal stated by officials is to land a human crew by 2024. and the location being targeted being the South Pole region. Now, further on into the decade, you notice that there is a date of 2028, which has been discussed by officials as being the start of a sustainable phase for the lunar program, at least the American lunar program. So that approach would make use of the Space Launch System that's been prepared for many years now, and the Orion spacecraft, along with lunar landers that are being developed, and also a lunar gateway that, at least initially, might involve a fraction of the elements being thought of for it. So it's in an orbit around the moon, and but it will be focused on serving these surface missions. One of the things that is interesting is that the capability of that gateway initially has been discussed by Scott Pace, the Secretary of the National Space Council, as potentially being a fuel depot. So you have to imagine a fuel depot in lunar orbit now. NASA has moved rapidly to announce the solicitations called BAAs to get proposals from industry to get these transportation elements procured. So this is a private-public partnership. And a few days ago, actually, the agency posted on its Next Step website, Forrest, that would be the next chart, its intention to call for proposals on an integrated human landing system. And that includes descent, ascent, and transfer element to actually achieve the lunar landing. So what this means is that the procurement process is engaged, the budgetary process is engaged, and both the administrator, Brendan Stein, and Scott Pace have spoken recently of the need to make these landers reusable and refuelable in space. And that, like I said, the initial capabilities of the gateway would serve that function. So ISRU, as you notice in this page, is features an Appendix D to those calls for public-private partnership technology development. So ISRU is definitely part of this discussion overall. And so what this brings up for us as a community is, what does this likely look like for the next decade for ISRU researchers and technology developers? So our first question, I'm going to address it to Diane first. And since the things are in motion at NASA that point to sustainability, is ISRU likely to be part of this sustainability? And if so, what kind of ISRU could be featured in NASA missions during the next decade?
Thank you, Laurent. So certainly NASA has plans for including ISRU. When they say sustainability, I think that's pretty much one of the first items they mean is sustainability. You mentioned the refuelable landers. So that is kind of our first target, is to refuel the landing stage so that it can go back up to Gateway. Whether it goes back up and then it's empty at Gateway and gets refueled again from Earth, or eventually even give it enough propellant to get up and back down again. That would be great. So we're looking at that as a target right now for the end of the decade, or that 28, 29 time frame. We're talking somewhere on the order of 10 tons of oxygen or 10 to 15 tons of water that we want to mine.
And I'm sorry, I did not catch the date. I think you were a little bit muted.
Sorry. So as you mentioned, the target is at 2028 or 2029. for the first sustainable portion of NASA's mission. So that's when we would be aiming for maybe refueling that lander with somewhere around 10 tons of oxygen or 10 tons of oxygen and fuel made from the water, 10, 15 tons. So right now, NASA has kind of a parallel path. We are, of course, interested in the water in the permanently shadowed regions. A lot of challenges still getting into them. We really still don't know exactly how much is there, how deep it is, how accessible. So while NASA's working technology development for that and looking for that from outside, we're also still looking at getting the oxygen out of the regolith that's available anywhere you want. So it's a parallel technology development path. We've been talking already about, when do we want to start flying ISRU? You're not just going to show up at 2028 and fly your first plant. So, we're hoping for some, maybe a pilot plant, maybe in the middle of the decade, maybe some components. The first chart, the Forrest showed, talked about the small scale landers. So maybe we could fly some components in some of the small scale landers. Anytime someone asks me about flight demos, I always say, well, if you're going to pay all that money, you better have a good reason for flying it. So you want to fly something that you need a lot of dirt for. You need a lot of the real dirt. So either that's a chemical reactor that you need the real dirt for because our simulants aren't, we've gone as far as we can, or it's the devices that dig up the dirt or travel across it, and you need the large areas of that abrasive dirt, and we just don't have big enough chambers to be doing that for extended periods of time. So those would be my objectives for any early flight demonstrations, is the hardware that needs to touch the dirt in the vacuum environment.
Okay, very well. So is there a two-pronged approach in terms of the type of resource, water and others?
So yes, water from the soil, and then also oxygen out of the regoliths. So that was the primary focus, factoring constellation, because we were just starting to learn how rich in water those permanently shadowed regions might be. For getting the oxygen out of the regolith, there's probably 20 different processes that have been talked about. The three or four that we did the most research on, a decade ago, was the hydrogen reduction, the carbothermal, and the molten regolith electrolysis. But there's certainly other options that people have looked at. It's always going to be an end-to-end system balance. Mass of your system, power needed, yield that you get out, and how robust the system can be. Can it operate for 300, 500?
Right. Okay. Very good. All right. Any comment from all of you before we go to another question?
I'd be keen on. Hi.
Yeah.
I'd be keen on knowing whether you consider regolith as a building material at all, because it sounds to me like you're focused on extracting maybe water or maybe oxygen, but the actual regolith in itself as it is, as a building material, I didn't hear anything about that.
Thank you for keeping me honest there. I should have mentioned in my introductions I'm a rocket scientist. So I got started in propulsion research, and that's how I got started in ISRU. So yes, I'm sorry. I always think about the propellants first. And of course, it is your big consumable, your 10 tons or something. But we certainly are looking towards probably first the simple civil engineering that we talk about. Maybe sintering down a landing pad to cut down on dust, or building a berm to protect your landed assets before your next one comes down. But there are also NASA projects looking at building either simple structures, to again protect the radiation shielding or things like that. And then in the future, yes, maybe more complex structures with the construction. So, yes, we are thinking beyond. Probably the first use is propellant, but quickly we would want to move beyond that to the other uses.
Great. We'll actually address a little bit that topic in a few minutes with another question. So I'm going to turn to Gary and Jürgen. We noticed that obviously the South Pole seems to be a destination of choice for NASA. The Chinese National Space Agency also has interest there, and other private actors. Is this also the case that you hear in discussions in Europe, or are there other locations on the moon that play over there?
I think Jürgen maybe can answer that better than me. We've been, in Luxembourg, we've mainly been looking at what are the markets that are going to start up. And, you know, I think we're interested in wherever a major agency decides to start building up capabilities, because I think many companies and private interests will use that as a leverage. But Jürgen may know more about the actual locations.
Thank you, Gary. I was actually hoping that you might know something that I don't know, but
don't tell me we have to call someone else.
No, so the story is there have been people looking into a polar landing site, of course, and there have been discussions about polar landing sites. But as Gary points out, basically everyone here is kind of waiting for someone else to take the decision. Which is why most of the work that I was involved in and that I'm aware of is centered around various resources, or like a widespread. So for example, in my work, I considered always like all possible regular sources that we could find no matter where we land. And I think actually, even if we fly to the pole, until like we have decided for a location, we have samples, we still have to kind of like have a process or develop technologies that are capable of treating all sorts of regolith. And I'm never the biggest fan of people like telling me they use 100% ilmenite for their experiments or some things like that, because I don't think we get that lucky. So landing site, yes, of course, will be important, but at the moment, at this stage where we are, I think the approach of being very flexible and simple with the methods and experiments we run is the way to go anyways, till the decision is taken. But no definite answer from like ESA side that I could say like that I have heard.
Can you give an idea of how this vision of the lunar village is evolving over in Europe?
Well, I guess Jan Werner, our dear boss at ESA, is pushing forward with it. And I think like short, now how do you call them, short turnaround experiments are running, and like more and more sites at ESA and more teams looking into extraction of oxygen. New facilities have opened. Finally, I hope at the end of this year, I know I said that last year as well, we hope to see a Lunar Dome, like a high bay actually. It's not an inflatable temporary structure anymore. It's going to be a permanent structure at ESA, where we're going to have like a test site indoor with a large sandbox to test surface operations in particular. This is also like the corner where I'm coming from. So human surface operation, robotic interactions. We're doing a lot with virtual reality there to try to simulate operations already, and we hope to enhance the capabilities with these facilities there. So
I did want to add one thing to the location, and I think it's the obvious for people in this area. You know, there's these areas, and especially on the poles, where you get more light than you would on the equator. You have less of the night. And I think those are going to be really interesting areas, especially if they're the ones that are near potential resources, especially ice and water. So I know there's a lot of new emphasis looking at that when you ask for locations that are important.
Right.
Yeah, I think that's a good conversation that we can get more feedback to right now, is what really determines a good landing site. I think like Gary's point is really good, that, you know, having additional light source, especially if you're going to be using it for power and other things, is highly important. And then also being close to, you know, resources, obviously, where there's potential for water. Permanently shadowed regions are a very interesting region that hopefully we can get down in and do work inside. And then other features that might provide shielding or radiation protection from a landing site, that could be like lava tubes, That's another type of ISRU resource, right? Is just using the features of the ground that are there. So I think all three of those things are things that I've been thinking about as I've been looking at potential landing sites. And then the last one, because of my subject matter area is descent GNC systems for lunar landers, is really like what can we do in a landing ellipse, and what can we do during blind landing versus vision, enhanced navigation. So I think there's a combination to zero down on the right point. Does anyone else have other comments on what would be the one killer thing that would help you, put a landing site on the top of your list?
Go ahead.
I think it needs several things.
Yeah.
Engineering requirements, resources. Engineering requirements can be driven by the environment, but if you have good enough technology, that might be less important. If you look at the Chinese rover, for instance, it has to be shut down when it's really hot. So thermal requirements are a major concern, I think, and I don't think we have that all down yet. So that's probably going to be a major one.
Hey, this is Chris. I'd toss in one of my thoughts there. I think one of the first things we need to do is settle some of the uncertainty around operating in the regions. And that, I think, comes about from, we got the possibility you could extract oxygen from regolith. You've also have, we know that there's ice within the PSRs, so we naturally want to go there and find the ice. But there's a lot of uncertainty about the kind of, at what depth do you find the ice? How much might you find near the surface, and how it's mixed with regolith? So I think in a near-term kind of landing goal should be land somewhere where you can help settle all those questions, and then might help you design the next, make a decision about what is the right direction to go in the near term for resource extraction. For instance, is there a way we can get to the ice, particularly water ice, and operate there and extract it and make propellant from it? Or is regolith, which you can find almost everywhere on the moon, is it the better source for oxygen as a repellent? As everyone knows, it's most of the mass of your repellent is oxygen. But if you're only going to extract oxygen, then you have to bring the fuel from Earth. But then actually, if you start working with regolith, you can do all these construction things and start working on metals extraction and those kinds of things. So I think a first landing site should be chosen to help settle many of the unknowns we have about use of resources from the moon.
Yeah, that's a good point. Actually, this very strong interest in the South Pole water resources still hinges on whether we're on a ground truth mission. So NASA had a resource prospector mission in the planning phase and hardware development recently, and I just read that Scott Pace actually admitted that it was something that NASA probably will need to revisit to actually incorporate this in an early mission. He called this maybe a misunderstanding within the NASA decision making that the RP mission had been canceled. So I think we're looking forward to these missions to confirm whether the South Pole is actually a good place to go in terms of resource, notwithstanding the fact that, just like Gary pointed out, it's an attractive place for solar power generation. So let's go to another question where I was wondering, we're talking mostly about private government, but several private companies are showing interest in developing space transportation elements that would fit in all this. And that would be refuelable in space. Does it seem that these private entities want to develop ISRU capabilities themselves, or are they kind of waiting on government to do that? Who wants to take this?
I'd like to add one point that will help the discussion, I suppose, because we haven't talked about the use case of the base. Because if the lunar base is going to be a pit stop, let's say to refuel spacecraft, that's a whole different story than we use it as a science base for lunar research. So yes, if it's a pit stop and like we fly to Mars from there, I can imagine private industry being really interested in this and kind of like building up an industry. But if it's a equatorial research base, then probably not so much, I think.
I see. So you're talking about a surface base that would be a propellant factory, basically.
Possibly, yes.
Yeah.
So I think basically what he's saying is it depends on what the market is. And, if it's a big market, then the commercials will come in. And that's always been the case, right? When you're just doing one or two things, there's no profit for a commercial entity to build one or two. And that's why it's always had to be government funded. But as soon as you're talking about moving on, and NASA's plan is supposed to be Moon to Mars, then either it's a base from the surface or the base back up in Gateway where you bring more propellant up to Gateway. But it's certainly NASA's objective is always technology development to get it to the point where the commercial, especially now the public-private partnerships, to get it to the point where the commercial entities are, the government's bought down that really high-risk stuff, and now the commercial entities can come in and take it on to the independent state. So I'd like to see the commercials come in with an ISRU plan eventually. Hopefully, built on the great work that we're doing here in NASA and the other government agencies. But that just lays the foundation, hopefully.
I think that's a really good point. This is the issue. Even when I was at NASA, is that it's not clear what the vision is of the United States or of China or of India about what they actually vision the moon as being. So if they really see it as a part of the economic sphere, it'd be great if they would, and they talk about permanence, that they would look at that in their long-term systems that they put there. What was Diane just brought up? Is it something that's going to be short there and that NASA will demonstrate technologies, or are they willing to buy resources and regolith products and metals from commercial companies for a permanent base kind of thing? And if they said it was a permanent base, let's say 10 years they find the best place on the moon to be, then venture capitalists or any people, investors, would put money into companies that plan to make that their business case. But because there's so much uncertainty right now, it's very difficult for any commercial people who are not self-funded to get the funds to kind of get to a point where there'll be a critical mass of activity going on in space. And I would like, for one, to see NASA work with the other space agencies to talk about how they could set up a permanent base or a permanent or whatever it is that they want, robotic activity. But if it was permanent and that they were willing to buy things from companies, it would really push things forward quickly.
Yeah, it goes to really the core of the definition of this idea of sustainability. I mean, it is a catch-all phrase for program, but we don't have a definition of what sustainability means for the different agencies, and whether that involves just repeated missions or that are affordable, or actually growing an infrastructure on the lunar surface. Yeah,
I can say that as as a employee of a private spaceflight company, you know, we at Draper, we're really focused on, you know, providing a lunar transportation solution, and we're responding to the needs. So NASA's put out these calls for new opportunities. They want to move stuff to the moon. But we really need, you know, the market to invest in, you know, ISRU technologies. But as far as we're 100% excited about the more activity and the more moving between the moon and maybe, you know, other points in cislunar space or deep space habitat or deep space gateway, is the more of that is better for us, but we really need long-term, I guess, predictability.
Right. Okay. I wanted to bring up another point that so following the fact that like officials on the American side discussed the need for a lunar base at the South Pole region, and the head of the China National Space Administration also stated last week that the agency intends to build a research station in 10 years in the region of the South Pole. And so what I'm picturing is this really push for this region, and now we see a suite of landers of different capabilities, maybe returning to these places, and as these landers grow in numbers or in thrust and payload capabilities, we're also kind of discussing in the community the potential impacts of these landings on the landers themselves and on the surrounding assets if you start having something that is kept on the surface to continue work, particularly in ISRU, and impacts from ejected materials from the repeated landings, and impacts on the resource deposits themselves, if it is water at the surface, and imagine material from these landers, from these landing plumes coming into the resource deposit. So what role could ISRU be called to play to establish the right surface infrastructure in a sustainable phase to actually address these kind of issues? Who wants to take this on first?
So I think I did touch on this earlier in response to another Jürgen's question. So we've been working some design studies. Hopefully I'll be showing one of those at the upcoming Space Resources Roundtable in June, but, where we have said, okay, if you're going to land a lander, make a bunch of propellant, but now you need to get it to the next vehicle, and the next vehicle you need it to land close enough so that you're not driving your product, kilometers away. So, but if you land it too close, then you got the concern about the ejector. So can you take those same excavators that we're supplying regularly to your processing plant, and can those same excavators build a burn? Or during Constellation, we looked at just scraping away the top layers. Maybe that's all you need to do to get down to the super compact. Or maybe while you're scraping it away, you build a little bit of a burn, but you scrape it away. Or essentially, maybe you can use that same solar energy, direct solar concentrators that you're developing to provide energy into your reactors, and use that same technology on a mobile device to center it antenna. So those are the first looks we're taking at ISRU to change the environment to be more ready for a lot of activity and repeated landings. We've also talked about using the excavators to build, maybe dig some trenches if you have to put a nuclear plant some distance away and you've got to get some cables. And if you're going to be driving around with rovers, you don't want to be driving over the cables, so maybe a plant. So those are some of the uses, the next steps when you get into civil construction.
Okay, yeah. Mm-hmm.
I think one of the things I want to comment, I think this is similar to what Diane just said, is that the to have, as you asked, infrastructure, sustainability, I think one of the things we would need to see is interchangeability and kind of standardized components, or where like reusing a excavator that was intended for one purpose could actually be used for other things. By having standardized systems, you could approach different vendors. If you're going to do this commercially, so the commercial vendors need to know what they're building for. If you have one-off systems that are built by one unique company, you're probably not going to get a lot of, you'll be at some point locked into that system. And I think you need to have possible multiple vendors for different systems, even if you in order to have pressure to keep costs low. Over time, you usually see costs grow, particularly if you're locked into a single possible vendor. That's just one thought I wanted to bring up.
Yeah.
Thanks, Chris. Do we want to take a couple questions from the viewers? We're getting close to the end.
It's a good time for it. Sure.
So we have
What do you think?
we have a couple questions. The first one is, let's see, from Koki Ho, professor at University Illinois and Georgia Tech. What is the rough size / mass of the first ISRU plant stage that NASA or other agencies plan to send to the moon? So that might be a good one for Diane.
Yes, so, well, I don't know. So as we mentioned, our goal is something around 10 tons of oxygen by the end of the decade. Exactly how big that plant might be, that was actually the question we were addressing in some of the design studies we've been doing. We don't really have numbers right now. Like I said, we're trying to finalize those, the most recent design study we did, and I plan on presenting it at the Space Resources Roundtable. But would that be the first thing the question said, what's the first thing you would want to send out? So let me just talk about what we were talking about for Mars, because we're thinking of a similar approach for the moon. So on Mars, we had a certain amount of production, and we said, and we want some amount of redundancy. So we said, well, maybe we would have 3 separate modules. Each one would do a third of your total rate. Or on Mars, we said even half of your total rate, so you could have a full redundancy. So now you cut down that full rate to a half scale or a third scale. And maybe that's small enough that you can just fly one of those on as your pilot plan. And so by flying one of those, you're not flying subscale, you're flying a full scale module, and then all you need is multiples of those to get your eventual production. Or even if that's too big to fly on the early landers, maybe you can fly something that's a half or 1/3 of one of those half or 1/3 modules. And so now you're saying, well, okay, it's not full scale, it's 1/3 of my full scale, and then I need 3 of those for my full scale. But we're trying to come up with a way where your first thing that you fly does not need to be scaled up 10 or 20 times, because then you're stretching the realism and the feasibility. Did you really demonstrate your final system, or is it just a demonstration of a way to do ISRU, but you really need to make too many scaling changes? So we're trying to come up with a way that by going modular, the first thing you fly can be a very close scale of your eventual full scale.
So Diane, I have a quick follow-up with that. The requirements for the ISRU system for Mars is largely based on what's needed to make a Mars ascent vehicle successfully launch into orbit and mate with an Earth return vehicle. For the moon, would you use this similar type of size of vehicle, a number of people, and a lunar ascent vehicle as your baseline for that system, or would you look for something larger?
Actually, for the moon, we've been talking about the lander more than the ascent vehicle. So the 10 tons of oxygen comes from using the lander by launching it back up, either all the way to Gateway or back up to the low lunar orbit, where a tug would take it back up to Gateway. That would be a little less propellant. If it goes all the way, it'd be more. If it goes all the way up and down, it'd be more. But we're looking at the reusability of the lander as opposed to the ascent vehicle. And one of the reasons we're looking at that, first of all, that's an element you need every time. We also had more challenges during Constellation in convincing the astronauts that we were going to land their ascent vehicle empty. Because for the lunar mission, the ascent vehicle is always considered your abort to orbit scenario if something goes wrong during descent. And so they were very hesitant to say they're ever going to rely on ISRU in the ascent vehicle, which meant you have to land that empty. But now with the push towards sustainability and the gateway there as your basically the gateway to the moon, where you're going to be refueling. Originally, you could refuel those landers. They can be designed to be refueled, and originally you refuel them with Earth propellants. But then that same lander could then be refueled later with ISRU. So that's why we're focusing on the lander, and that's where that 10-ton base, starting number comes.
Okay, thank you.
Jürgen and Gary, do you have is there a discussion of a similar approach over in Europe in terms of like small scale ISRU trials on the surface and then building up to a target that has been already discussed?
I believe that's Jürgen's question. Go ahead, Jürgen.
That's okay. First, quick question. Did I see that correctly on the timeline that you showed at the beginning, Laurent, that the lander size is about, that NASA plans to send is about 5,000 to 6,000 kilograms? Do I remember that correctly?
Yes, that's one. Yes, that's the number that.
Okay, just because I think someone was asking for size or like dimensions, and I think that is what I had in mind. So to come back to your question, yes, ESA is looking into like small scale experiments first to see to test some ISRU principles. For example, I know of one experiment that is planned where the idea is to send some hydrogen to the lunar surface and release it over regolith and see what happens under certain temperatures. Ideally, also some fluorine, but as probably all of you know, fluorine is always not so much fun to fly. So yeah, ideally that would also be the case, and then small scale, and if it works and we see the first results, then to scale up and fly a larger system. Yes, that's the idea.
But the larger system is not bound in terms of, just like Diane was describing.
Well, I would say ESA's interest at the moment, at least, in like from what I can tell, not speaking for ESA, but like knowing a bit about it, is the moon first. So like there's no big Mars plans that come afterwards. It's just like to get everything done and working on the moon. And so yeah, everything is kind of designed for the moon, if this answers your question.
Okay. Yeah, the capability of production is not stated, like, for example, 10 tons of oxygen for a year or so, something like that.
Yeah, maybe, but not that I'm aware of, no.
Okay, all right.
And we have one last...
Do we want to take one last question?
Yeah, we have one last viewer question. It's Ross Centers is asking about what are the panel's thoughts on getting power inside permanently shadowed regions?
Okay. Who wants to take this?
Well, I could answer like, well, for getting power into the permanently shadowed regions, I think mirrors is a quite good idea, but I'm very biased towards this topic. So, yeah.
Well, tell us about your bias.
Well, so for the last years, I've been looking into like how we can manufacture glass from lunar regolith and like get that glass to good enough quality to surface coat it. So I've successfully built some mirrors and some arrays of mirrors. And once you have mirrors, you can basically direct your light from wherever you have it to wherever you need it. And that also possibly over larger distances. So that could be one of the ideas to get some energy there in the form of sunlight. It also depends on your use case, whether you need heat and energy in form of heat, or you need electricity in that area. So, yeah, but that's one possible idea, and that has shown to work, at least on Earth yet. So.
Yeah, I'm a little biased as well. We've been thinking along the same lines, particularly focusing on, although deployables or inflatable structures that would erect a heliostat type structure to direct light into the PSRs. And probably people know of Stokia's NIAC Phase 2 that kind of talked about some of these, did some work on this in this area. If you're interested, you can find the that NIAC Phase 2 report on the NIAC website. There are people talking about some other ways, like lasers, or to say photovoltaics on the crater rim, and then beam power via lasers. That's a possibility. And the other thing people talk about is putting a nuclear reactor down that simply land within the PSRs to supply power. Those are some of the things I've heard spoken about.
Very good. Well, I think we've reached our time that we wanted to spend. So I think I want to thank every one of you to participate in this first historic hangout of the AIAA Space Resources TC, and given the interest on YouTube, I think we're going to continue with this momentum. I think it's fair to say that we'll probably revisit this very theme, because there's a lot of ground to cover and a lot of themes to explore within it. So one thing I wanted to say is that this is recorded, and the intention of the TC is to make it available on our Facebook page, and it will be available to all who want to access it, to learn about what we do and what the community does. The TC, before I turn it over to Forrest, the TC will meet at the Space Resources Roundtable, which is a conference on ISRU, focused on ISRU, and at the Colorado School of Mines in June. And so we hope to see you there. And with that, I'll turn it over to Forrest. And thank you very much for your interest.
Could I just jump in and tell, you said June, maybe to be a little more specific, June 11th to 14th here in Golden. Also the agenda, which may still be a preliminary agenda, but you'll see an agenda coming out in the next few days. So hope to see people here in Golden in June.
I'll be there.
Great. Well, thank you all for joining us today. Please also leave your comments in the video after this live stream ends. There'll be comments below, and we'll take our time to answer those as best we can. And we're going to plan a second hangout. This is going to be May 19th at 9 p.m. So that will be a Sunday in the evening. So we're mixing up the times to try to make it easy for everyone across the world to join us. And we'll probably alternate every other month at these 2 different times. We're looking for theme suggestions, so that's another thing that you can add in the comments below. If you have a theme suggestion, or you can post it on our Facebook page. Please like the Facebook page. That's our place where it's easiest for us to get out information. So that's just facebook.com, aiaa.sr.tc. All right. On behalf of the Space Resources Technical Committee, thank you all for joining us, and we'll catch you next time.